1.3 is another nice little review section. Looks at some different things we can do with algebraic expressions. So I'm going to kind of pick and choose here. Some of these are pretty easy. So let's make sure everyone remembers this one. So when I have a quantity squared, what that means is that I take that quantity and multiply it by itself. So here I would not be able to distribute that exponent, and the reason why is because of the subtraction. So if I have a sum or a difference there under the exponent, I can't actually distribute the exponent as I could if I had a multiplication or a division. So instead I need to say, okay, so I'm going to write the quantity squared as the quantity times itself. And then I'm multiplying two binomials. I'm going to use the FOIL process. So I multiply the first, 2x times 2x, 4x squared. The outer, 3 times 2 is 6. The inner, and the last. And then I combine any like terms. My linear terms. Okay, here's another one. I would use the same FOIL process. Okay, so what about square root of y times square root of y? A couple ways of thinking about that. I can say, well, that's the square root of y squared. It's y, right? Or I can say, well, that's y to the 1/2 times y to the 1/2. I add the powers, and it's y to the 1. Okay, the outer, that'd be minus square root of 2y. The inner, plus square root of 2y. And the last. So I have minus, then I have root of 2 times root of 2. So it's kind of like this, right? So if I take root of 2 and multiply it by root of 2, it's the same as root of 2 squared. It's 2. Then I'm going to combine. I see these like terms in the middle here. Oh, they cancel. So there's my final answer. Okay, so what about going the opposite direction? So instead of expanding, what if I take some polynomial, or in this case I have quadratic expressions even, and I factor those. So I want to write them in factored form. So you should remember this pretty well. So my lead term is an x squared. So my lead terms and my factors would need to be x and x. So how does this work? I have to look for numbers that add up to 4 and multiply to -5. Let me see if I can turn the brightness up here. I guess not. Oh well, I guess it's bright enough. Let's see. So what are my numbers? So a plus b is 4. A times b is -5. So usually we look at the product here and we go, okay, so things that multiply to 5, like 5 and 1. Then I go, which one would have to be negative? The 1 would have to be negative in order to add those up and get a 4. So I'd have a +5 and a -1. Okay, so I can check that. Let's see, I'd have an x squared minus an x plus a 5x is 4x minus 5. So it checks. Okay, the one where I have the lead coefficient, the 3 in front here, that one's a little more interesting. So I have a couple options. So let me see if I can figure this out. I mean, most people do this by guess and check, as in, well, if I need a lead term of 3x squared, I need a 3x and an x. Okay, and then I know my constant is a 5. So I mean, I need a 5 and a 1. And then I kind of guess and check, like which one goes where. I mean, if I put 5 and 1 here, then look at this. You see how the middle term there, I need that negative. So I guess both of these would have to be negative. Let's see if this works. That'd be 3x squared minus 3x minus 5x plus 5. That would be good and that would be good, but that'd be negative 8, not negative 16. So it's close. So what if I reverse the 5 and the 1? Does that work? Let's see, 3x squared minus 15x minus 1x plus 5. So that does it. So that's typically the process that we use. Guess and check. Here's a special one. I bet you've seen this guy before. This guy's called a difference of squares. So those guys have a special factorization. So x squared minus 16, that factors x plus 4, x minus 4. Because if you think about foiling that out, with a difference of squares, those middle terms cancel. Okay, so generally speaking, I could say if I have x squared minus a squared, I can factor that x plus a, x minus a. So here's a fancier difference of squares. I can tell right away that my first and second term, I mean, those are both perfect squares. So I know I'm going to basically use that a plus b times a minus b factorization. Let me see, 3m times 3m is going to give me 9m squared. Okay, so 25n squared, need 5n and 5n, right? 25n squared, and then 1 positive, 1 negative. Should I double check it? 3 times 3, 9m squared minus 15mn plus 15mn minus 25n squared. And I get back what I started with. Okay, so again, going kind of quickly through, I mean, this is review. This is from like math 12-15, introductory algebra stuff, really. So when I see 4 terms, 1, 2, 3, 4, the process that I think of for factoring that is factoring by grouping. So what that means is I may not have a common factor, so I look for a GCF. That's really the first thing that I do when I'm factoring anything. I'm going, is there a greatest common factor? like something that I can pull out of the whole expression. Well, no in this case, because I mean I can't pull anything out of x squared that I could pull out of, say, 2. These 4 terms would have to all be divisible by a certain factor in order for there to be an overall GCF. However, what if I group the first 2 terms and the second 2 terms? Then looking at my first group, can't I factor a GCF of x squared out? That'd leave me a 3x minus a 1. In my second group, I can factor out a 2. Double check that before you go on. Let's see, that'd be 3x cubed minus x squared. That'd be 6x minus 2. Okay, so we're good so far. Now I have a GCF overall. You see how this 3x minus 1 appears in the entire expression? As in, I can take that 3x minus 1 out front now. And what will be left? An x squared plus a 2. Okay, now you can check that. Look, if I was to take this and distribute it, let's see, I'd have an x squared times a 3x minus 1, and then a plus 2 times a 3x minus 1. Isn't that what I had here? So indeed, that's the correct factorization. Okay, so let's see, I think these are the last couple. With these, really what I'm interested in doing first is I'm saying, what the heck do I start out with here? If I'm trying to factor, I'm going to pull out the greatest common factor. Okay, so what I'm going to do is I'm going to pull out the lowest power of x. What is the lowest power of x that I see here? I see this -3/2. So I'm going to take that and I'm going to take that out as my GCF. Okay, so then I'll have a 1. I'll have a 2 times an x to the something. What the heck goes here? So I got to say, what number minus that 3/2 would give me my -1/2? You see what I'm doing? I'm saying, so what number, that's m, minus 3/2 is going to give me back that -1/2. So what would that be if I add that 3/2? 3/2 minus 1/2 is 2/2. Is 1. Let me put it there and then we'll check, of course. Let me try this one. So I'm going to have x to the something. So that one I'll say, let me see here. I'm going to have n, this number here, minus 3/2 needs to give me 1/2. It's 2. Okay, let me double check before I do anything else. So if I were to distribute this, I'd have 1 times x to the -3/2. Okay, then I'd have 2, and then I'd have x to the 1 minus 3/2. 2/2 minus 3/2, -1/2. That one's right. Okay, what about this one? That'd be x. I'd have 2 minus 3/2. 4/2 minus 3/2 is 1/2. So look at that. Is correct. rid of that scratch work. So now I actually see this trinomial. So let me rearrange this in descending powers of x, because then I should be able to factor that guy. Okay, adds to 2, multiplies to 1. 1 and 1, right? X squared plus x is 2x plus 1. So then you see how I have that quantity x plus 1 times itself? And then the last thing, we don't like to leave negative exponents in the answers. So let me go ahead and move that to the bottom. So that's a nice one. And problems like this, like number 6 and 7, these show up in calculus. So actually when you're using some of the rules in calculus that we use for differentiation, we see this come up where you have to simplify these kind of complicated expressions with exponents. So let me see, that looks like it's supposed to be in the front as a coefficient. So what the heck do I do with this one? I'm going to do the same thing, just going to be a little more complicated. So let's say instead of the lowest power of x, I'm going to say pull out GCF, which is the lowest power of each factor. So I have to kind of look and see. So first let me look at constants. Like I've got 3 times 2 in this first set. And then I've got a half in the next set. So what should I do with that? I'm thinking, and sometimes there are, more than one idea with the constants. To kind of think, maybe I'll take out a 1/2 for the constants. See how that works out. Then let me see what else there is. So see these 2x minus 1s? There's a 2x minus 1 squared and a 2x minus 1 cubed. So that's straightforward. I'm going to take the lowest power, so that'd be the squared. Okay. Then there's the x plus 3s. Okay, so the lowest power there would be the negative. So all of this is the GCF. Okay, so what the heck is left? Here's how to keep track of everything. Okay, so let me see. So I pulled out a half. So let me see here. Half of what number would be 6? Let's go. All right, so here's my GCF. Let's look at distributing this. So if I distribute here, let's see, 12 divided by 2 is 6. I'd have 2x minus 1 squared. And then x plus 3 to the negative a half plus 1 is a half. Does that match this? 6, 2x minus 1 squared, yes it does. Okay, so then I'm distributing then to the next term. Okay, so that's just, I have the half. I have 2x minus 1 squared times 2x minus 1 is 2x minus 1 cubed. Then does that match this? Yes, it does. So that's correct. Okay. Then I just have to look and see if there's anything else I can do inside here. So I already have my factors. See how these guys are all already multiplying in the front? Like those are all already factors. Versus you see inside the parentheses here, see how I still have this addition? So that means I probably want to go ahead and let me distribute. So I have 12x plus 36 and then 2x minus 1. See how I can actually come in here now and combine these like terms? So 14x plus 35. Let's look through it one more time. Hopefully copied everything down correctly. It looks like it.